Alrighty, round two. Because the first round I realized I wasn't recording after I basically did everything. So hopefully this will be much quicker than the last video I tried to record. Oh boy. Anyways, let's go ahead and show you guys how I parse a PRC in how I intercept PRC parsing in Smash. So first things first, connect to your Switch with Ghidra. Boot your game holding L if you don't want plugins, or if you don't mind the plugins, or if they're not hooking into anything important. Anyways, I held L, so I'm booting into Vanilla Smash. Now let's go ahead and look for a hash I want to edit. So let's go ahead and look up stage saturation, right? Stage color saturation, alright. And then this is the hash that's used in all the stage parameters. Oh yeah, I also forgot to mention, whenever you mess with PRC stuff, I recommend breaking at the start of the game, because sometimes it parses them at the beginning of the game. Sometimes it parses them later, but for now, let's go ahead and look up stage color correction saturation, which is a float. So yeah, basically I'm trying to edit. Paste this in there. And we have it labeled already, so let's click on it. We'll go here, drag these two over to the side so you can see. And this is a function that's already labeled for us, parse stage color correction parameters. Okay, I'm fumbling up my words a lot, sorry about that. Anyways, as we can see here, where this label specifically uses over here, so we have a label here, 0x216300726 blah blah. Let's make sure that this is the right one. So yeah, this is a stage color correction saturation hash label. And then it checks a variable against that. If it is equal to that, then it does some more checks, and it sets pvar8 to the param value struct with the pcvar plus the variable. So I think this is actually the type. I'm not sure where that gets set though. It gets set somewhere, but this param value struct has the type and then the value itself. So let's see where else this gets used. So over here, else if it can't find the hash, it sets it to a void. And then if the type is a float, it sets a variable fbar21 to what it needs to be. So fbar21 here, let's see. I forgot to mention, but you should probably look around the plugin, the code where it's using the hash. So if we look around here, we could see that it's checking it in an if statement. So if the stage color correction is enabled, then do all this. If it isn't, then if it's enabled, then set these to default values, I think, yeah. And then if it is enabled, then do all the other stuff here. So get the stage color correction gain, stage color correction offset, then look for the hashes. So that means this will only parse the PRC if... Okay, my bad. It'll only parse the PRC if the stage color correction is enabled. So let's see here. PUVAR5, that was what the thing. Let's say F, okay. And then PUVAR8, it takes the value of PUVAR8 and puts it in FBAR21. So it loads the register here to S4. Let's go ahead and see where FBAR21 is used. It is used here, outside of the if statement, which means it probably sets it to the default value or the custom value in the PRC. Let's go ahead and break here before it stores the fourth register. So Control C, break at 0x here, continue. And now we'll let the game run. If it breaks while it's still loading, that means it's one of the PRCs that get read at runtime or startup time. And then, or if it breaks like after the stage loads or whatever, then it's probably like you can reload the file every time. I don't know, that's kind of hard to explain. Alrighty, so it should break here where this value gets used. So go ahead. Let's open up a stage that uses color correction. I actually have no idea which ones would be. Let's just use Battlefield, good old Battlefield. Let's go ahead and pick anybody. Ended up picking the worst character in the game. Alright, so we hit the breakpoint. Let's see the current instructions that are near. So let's print the fourth instruction. So it's set to 1. Let's go ahead and set the fourth register to 0 and continue. See if it changes the saturation. It doesn't, so let's go ahead and try it out in the results. We kill ourselves because Olimar, and I'm not going to play Olimar. Alrighty. Let's set this to 0 again and continue. Alrighty, it's gray, so that means there are probably some other values or variables over here that need to be changed to. But you could probably make it so that this one returns true all the time, and then I'll go to the PRC parsing. And then, yeah. But I guess result stage also uses saturation color stuff. But yeah, that's how you intercept PRC parsing. So let's go ahead and try this real quick, actually. var EBT here, and then... Okay, so if we just stop this, actually, we can use no-op here. And that should, in theory, skip this check. It won't jump. Because TBZ, I'm not sure what this T stood for, but branch jump 0 basically. So it's going to jump here, but if it doesn't jump there, it's going to go through the normal stuff here. So if we go back and try it again. Let's pick Battlefield. Battlefield, Seinfeld. Okay. Ish. And now let's go ahead and try it again. That didn't crash, didn't give us a second pulse, but we were good. And now we have... Let's go ahead and set S4 to 3. See if that works. Probably not, but... Just crossed. Okay, nope, it didn't. Alrighty then. This is whack, but hey. This char collector. Let's just continue. Alright, but you could mess around with it and see if you can figure out how to get it to work on stages that do have color correction disabled or enabled or whatever. But yeah, that's the basics of intercepting. So you want to see if you can find the label here. If you can, see where it uses it. And then if you can't find that, see where it, whatchamacallit, that's a param value. And then you want to see where it next uses it up. So it takes the value of that and uses it here. Let's go ahead and do a harder one. Let's go ahead and edit the... Oh wait, just continue. Let's edit the color of the hand over here. So instead of red, we want it to be blue. So since I actually recorded this video before, I already know the answer. But step 1, what you want to do is, well, find the file that has it. And in our case, it's going to be UI param common. Whoopsie. Let me just drink this. Common color table.prc. So this is the file that has it. So we're just going to open up PRC here. And then we have 3 tables in here: com color table, damage color table, and HP color table. So if we check com color table, we can see here that player 1's color is over here, where it has R, G, and B, and the ID here. So our first step is to find this table. So we're gonna go here, Control V, and here we have a bunch of references here. So I'm not gonna waste any more time on this. So over here, these all take you to a function that, as far as I can tell, doesn't get used at all. So this function over here, it has stuff related to it where you can find some parsing code for the team, where is it? The players formatting parsing code. But this function does not run at all. So this last instance, however, is in a place that does run it. So this function, from what I could tell, is actually a function that instantializes like all the major PRCs. So let's go to there. See where it's used over here in the instruction. Okay, so around here. So if we check this one, it's the color table. However, the color table does not actually get read until like a while in. So if we go in over here, the next instance of it is where it reads. So we have the damage color table, the HP color table, and then this time, the next instance. So not all instances of the hash show up here, but you can find it by scrolling down a bit. So let's go ahead and see if this one is color table. Yep, it is. So over here, it gets the common color table hash, sets the variable, and then goes to another section. So it gets a type. It checks to see if the type is some type, I guess. But I do remember that it has to be checking somewhere if it's a list. That's what it was. So over here we get the hash on color table, which is a list. So blah blah blah, and then we jump here. After that, we check the type, some global variable data, and then check to see if it's a struct. Okay, and then here we have this one over here. Let's check this. And this is the color ID, which is the hash of the one in here. The color ID, so I'm assuming this is where it gets it, yeah. Alrighty then, so this is the color ID. Then we go ahead and if the hash it's looking for the color ID, it's gonna go here, get some variables, and jump here and check if it's a hash. So it gets the hash of the color ID here, which is gonna be player 1P. Let's go ahead and confirm that. We're gonna break here. By the way, even though I did this before, I actually get lost in this function because it's too big. We're just gonna run this and patch it. No. Hopefully I don't get stuck in the infinite load. Okay, thank God. Continue. And then we're gonna just run this again. Alrighty. And now we're just gonna break there. So if we break there, it's gonna stop us as soon as we get to this line. This function runs when this matchable icon shows up, by the way, so it's gonna be a while. Alrighty. So now let's go ahead and right now the current instruction we broke at is before it loads the register. We want to continue first, and then this load register, so it takes whatever this is and loads it here. And this should be the hash. Let's print it out. p/x.26. This gives us a hash look like. Let's go in there and we get the player hash. And then, oopsie, I am getting distracted. Alrighty. So here we have the player's hash. And then after that, it goes to a function here. And if we go inside that function, we can see it does some other PRC parsing. So here, here, and then here, and then it does some math at the end. Okay, so let's go ahead and basically see here. So we're gonna copy this, see what hash this is, and spoiler alert is color R. Then this is color G and color B. So this function is what gets us the colors from the struct here. So what we could do now is just go back here, break over here. Well, actually, my bad. Yeah, we could break over there. So break at 0x. If we break before the, if we break on the BL, that means we could see what struct it is. What hash it is by printing out the 26 register or 0x26. But if we want to see what this function returns, as you can see here, it says W0 is the return value. Or not the return value, it's what gets returned. That means if we break here, well, actually, before we break there, my bad. Let's go ahead and confirm that this works. So, as we said before, to see PRC function, we want to see the PRC parsing. We go there. So, where it reads the hash, checks if it's equal. If it is, it sets the variable to something, then it goes and checks it in a switch case. And then it loads this variable into a uvar pipe, which means that after this if statement is over, we can go ahead and copy this, break at, continue there, we're gonna have to hit it, yep. And let's print, what was it again? The 8th register, so W8. So we got, we got a 0xFE, so let's print out 254, yeah, and that's what it is here, so 254. And then it's going to be the same thing for green, same thing for blue. Let's go ahead and edit this actually, so let's set W8 to 0. And then for green over here, we're going to go ahead and set this. So if we track this down real quick, so we see here, uvar9 is equal to green. Then we're just gonna go here, set the variable pvar6 to uvar9 whatever. Then pvar6 over here gets to the switch case. Then the value of it goes to uvar10, and that's registered w19 here. So we can just break here, break at 0x this, and then we can just print w19, and that is 54. So let's set that 255, and then our last one over here, it gets follows the same instruction. So uvar9 is equal to blue if it is, and set pvar6 if pvar6, switch it, and then we're gonna go through all these types, and then put it in registered 20 W. So we're gonna go here, and let's just break here. So break that 0x here, and now register 20 is what has it. So let's set 20 to 0, and now we can just disable everything, all our breaks, and see if the color changes in game. Oh boy, that's a go. Alrighty. And yep, looks like it's green. Alrighty, that's nice. So now we can just go ahead and enjoy our green. Alrighty, so now we have the color here changed, but let's go ahead and go an extra step further. So we know where it reads the colors. So over here, let's go ahead and rename it to read RGB, and then let's just go ahead and oh boy. Okay, so let's go back to the previous function that we were at. As I said before, this one returns on the X0 register or W0 or 0th register. So let's go ahead and disable or quit from GDB. And then we can go ahead and wait for a while, I guess, because it's going to take a while to decompile that big function. While we're actually waiting, let's go ahead and just patch back. Alrighty, we're in. So now this function is still decompiling. Oh boy, that's taking much longer than expected. Okay, there it is. Thank God. So now we have this, which reads the RGB variable. Oh, and this one's showing up now, so it's showing you what's on. Alrighty. So now we can go ahead and track this down. So uvar9 will break over here before. So before the function jumps to it, so we're going to break at. And then we'll break after the function comes back, which is going to be the instruction right after it. Because when this BL happens, it's going to jump to this offset. Go through all this, and then when it hits return here. It's going to jump back to where we were. And go to the next instruction here. We're going to break here. Break at. And then let's see where this variable itself gets used later on in the code. So we're going to scroll down until we see another one highlighted. And there. Okay, so here, this one also uses, so we're going to go here and see where it's stored. So it takes register 20 and stores it into register 19 plus 28. So we're going to copy this. Break at. And now we have 3 breakpoints. So the first breakpoint is right before it calls the function. Because that way we can print out the 26 register and see what the hash is. Then the next breakpoint is right after the function is done, and we can see the value that it returns. And then the third register is when it saves the variable to the pointer it has here, or array, whatever it is. So now we can just go back here and see. Let's continue, and we should hit each one in order. And it's gonna take a while. Alrighty, so first breakpoint now. Let's go ahead and print out the 26 register. See. Other X26, my bad. And then we're going to copy this hash. Confirm that it's player 1. Alrighty, and now we're going to continue to our next breakpoint. So our first breakpoint broke here. And then our next breakpoint is going to break here. And now we can go ahead and print the value. So this function brought back 0xx, 0xff09. But as you can see here, it actually does some byte shifting to get all the colors on one variable or one number. Let's go ahead and note this down as player 1 color. And then the next variable here, the next breakpoint, number 3 is gonna be, where was it? Let's click UR9 and scroll down for users used. Okay, here. So now it's gonna take the variable that got back and it's gonna go to register 19 plus 28. So this one sometimes might be like this PUR 45 plus thingy. But this is just an approximation because this is an array to Ghidra, I think. I don't know, it's an assumption, but I recommend looking at the assembly more often because it's more accurate. So register 19 plus 28, so let's go ahead and print that out. An integer pointer, so register 19 plus 0x28. And my bad, I meant unsigned long because that's what the function returned. So this one should get us nothing or garbage. Okay. And now let's go ahead and print out our current instruction, see how we have W20, W20. This one is going to be stored to wherever this is, so let's go ahead and continue. Let's first print W20 so you can actually see what I'm talking about. So this one is the same thing as that we got before, so the color. Let's continue once, and then print out the same thing that we did before. And now we have the value in decimal. Print on hexadecimal, and yeah. Let's go ahead and watch this, so when the game wants to access it itself. So we're just going to do an A watch, but it's going to tell us that it can't be implemented. The reason is because you can't watch with registers. You have to get the address, so. The register 19 is a pointer. You have to get the pointer. And then you're going to have to replace register 19 here with the pointer itself, the address. Now we have the same thing, so we can go ahead and watch this. So A watch. And now whenever this gets accessed, it's going to go ahead and tell us basically, so we can see what it does. And let's go ahead and continue. We're going to go through the same loop again, which is oh boy, I lost that already. Okay, there. The same loop, which is going to be this line first, this line second, and then that line third. But for this time, we only need the first and second. Oopsie. Player 2. Continue. And this is player 2's color. And then let's just go ahead and do that. Player 2 color. And then we can just disable all our breakpoints, info break, and enable our watch point, so 4. And now you're going to go ahead and continue. So now we have player 1's color and player 2's color. Now let's go ahead and run it. Go smash. And, ooh, we hit the breakpoint. So here something's trying to access the color. Let me just move this here. Distracting? Okay. So the color here, let's see what accessing is. So we can just get the current PC and jump to that function. So this function over here is loading this to register 10. So yeah, it's loading it from something here, but this function doesn't have any obvious clues on what it's doing. But we know this function is at least loading the color for a reason. Let's go ahead and continue. And another function is doing it. The same function. Ah. But yeah, so we're just loading the color. We can get the PC again. And the same function again. Such as with the usual command, which is PC LR. Alright. So just gonna do the same thing, so let's continue. And then let's go ahead and enable the breakpoint again. And something else accesses. Let's get the current PT. And then this function did. Okay, but basically you get the point. You can see where it's using the variable. And now you have normal red. So let's go ahead and go back. And then let's go ahead and info break. Let's get this and set it to the blue color. Player 2. Continue. Go back on stock. And it's blue. So the next time it gets a new modified variable. So what's next? I guess that's actually about it, because that's how you can track down PRC functions and stuff. Let's go back here real quick actually. On RGB. So as you can see here, it does some math with the variables. And FR12 is what? UR5, which is red. You know what? This is only 26 minutes in. Alrighty then. I'm gonna just go a bit more. Let's go ahead and open up command prompt. Like that there. Oh boy, I have way too much stuff. Productivity GDB switch. Alrighty. Go ahead and open that up. Alrighty, and now let's go ahead and re-implement this function. No, not this function, let's re-implement the result of this function. So if this thing would stop freezing, that'd be appreciated. Okay. Let's go ahead and make a new script. Let's call it color. Alrighty then, now let's go ahead and just... First, I'll move these to the side, because they're just gonna get in our way. Actually, not entirely. Let's copy this and this. Alrighty. Just drag this to the side. Alrighty, and this one I want to keep that up. Okay. Color ID, color hash, player 1 is going to be from struct. And then for children, color R is going to be U8. And then, oopsie, color B is going to be 54. And color G is going to be U8 and 54. Alrighty. So now, let's just comment all this out. And re-implement the function. Oh boy, okay, my bad. Okay. So here it gets the RGB variable. So let's go ahead and just type three variables. R equals 254, G or 254, and E is 54. Alright. We have our three variables here. The same thing that the game finds. Now let's start doing the math. So the game's UR5 is... Let me pin this up real quick. Oh boy. This pin is enter pin mode. Hopefully that works. Nope, it doesn't. Oh boy, this thing is annoying. And let's just put that up again. This pin's... Alright, let's see if I can enter pin mode now. Nope, I can't. Alrighty, so I guess I'm stuck with Visual Studio going down every time I click on this. So let's see here. UR5. It gets a variable. Okay, so UR5 is red. Let me just note that down here. UR5 red. And then what's green? UR10 is actually green, yeah. And then UR11. That's blue. Okay. And then here, so let's go ahead and copy this. So F bar thingy is gonna be red, so red here. By shifted by 0x5 divided by, and then we want this to be as a float, so we're just gonna go float. Alright. And then if F bar 12 is less than, just copy this code and translate that. In Python, this would be if, and then colon, and then indentation, and then that. Okay. And now next up, oh wait, we also have an else for this. And then the powf function is probably a math. Let's start from math import start. So we don't actually have an exact answer for that, so let's go ahead over here. Powf Python. Oh, so just pow. Let's see here if it has a float option. Alright, so it doesn't look like it has a float. Let's just use pow for now. So these are the two arguments. Alright. So this one gets us the F bar 12. And then F bar 13. Okay, we can just copy most of this actually. We just need to translate this properly. So F bar 13 is going to be U bar 10, which is green, so green. And then boop, boop, boop. Oh, it looks like it does the constraint for all of them. Okay, so we can make a new function here. Def get constraints. I have no idea what it's called. Bar. And then for this bar, it's going to be boop. Temp. And then we're going to return temp. Wait, does it use the same numbers? Yeah, it does. Okay, yeah, it all uses the same numbers. Okay, so get constraint. And then F bar 12 equals get restraint, constraint R, G, and B. This is F bar 13, F bar 14. Okay. And then we can go ahead and just copy this byte shifting stuff. I think in Python you have to do. Okay, so now they have the byte shifting stuff, we can just go ahead and res equals this, so unsigned long integer, so that's gonna just be a. We're just gonna copy this and do integer. Then the same thing here, so boop 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 boop. Okay. So the integer looks like only okay. Now that we have all this, let's see or by shifting. Or Python. Byte shift. Realize operating again. Okay, so for some reason I can't just do this. Oh wait, I think it has to be on the same line, never mind. Alright. And this should theoretically give us what this function returns. Let's go ahead and run it. So int x res python color.py. And this is a 0xff00. And that is not what we have here. We messed up somewhere. It's probably casting, honestly. So unsigned long. Oops, yeah, I think I was supposed to float this only, actually. Let me just confirm that there is no power for Python. Pow for Python. Upload. Okay, I have no idea where they get power from. Let's see if I can. Let's go ahead and try it out real quick ourselves. So, where's VS Code here? So let's go ahead and print. Let's go ahead and just okay, see this. I can okay, see this. Good boy. This is greater than actually. Go ahead and print out here. Alright, and let's go here, tab, run it. 996, 991, okay. So this returns lots of floats. And this logic here is a float too long of UXF, U R5 0XFF divided by 255, okay. Plus sign equal to, we divided by 12 divided by 2. And then this hashing here. So let's go ahead and actually and print F bar 12. Probably gonna give me a 0, yeah. Times 255.01. 252. Even though this is a 254. I guess that's accurate? I don't know. Alrighty then. Let's go ahead and just enter this. And then we're gonna go ahead and buy shift it by this much. Oh boy, okay, I think I see the issue now. So this part here. Although I don't see why this would be an issue if it works in game. Let's go ahead and just print this in hex. Oopsie, I meant terminal. Why did it take me out? Okay. Okay, reimplementing a function was not necessary, but I might as well try. Because I haven't tried this before. So we have the integer fvar21 by shift by this much. Or fvar12. Oh wait, it does it twice. Let's see what this next one is then. Let's run it. Alright, we get 252. Or oh wait a second, is this the issue? Probably not, but I'll try and see. Nope, that is not the issue. So FF. Let's print out green, so F bar 13. That's 09 times 255.01. Wait, why is green? Oh, wait, I see the issue now. Sometimes I make dumb mistakes like that. I apologize so much in advance. That was actually the issue. FF00G. Okay, that was not the issue. But that was probably... Oh. I am super sorry. Okay, let's go back. So temp. And var here is going to be... That was the mistake. I'm super sorry about this. Wasted too much time on this. Okay. So var here. And then temp is going to equal that. And let's go ahead and get rid of this. That still gives us the same thing. So let's just confirm that we're doing everything right. R, B, and B. Alrighty. F bar 14, F bar 13. Why can I not enter? That is super weird. Sorry, long 0x f 0, and then integer bar 12 for 14 times 1. Let's see. What if we just backshift the bools? Will that work? Oopsie, that's 4. 1, 2, 3, 4 floats. Okay, we can't do that. Oopsie, let's print out the res and hexadecimal. So the first two is FF. The second two, see, by shifting man. Okay, well, actually, let me put the last one in here. Okay, so see, okay, yeah. Let me go ahead and just delete all this and copy this line again. Alrighty. So an unsigned long. Let's go ahead and just. Oh wait, I think I see the issue here. Yeah, okay, yeah, that is completely my bad. So this is one payment itself here. Float this. And then yeah, okay. Float this. And the top one is the same thing. Float that. Float this. And now we just move these lines into let's go and try running this. Oopsie, let's change this to int. Let's see here, where is the float? Oh yeah, here, okay. Integer here. We don't need that int there. Integer there, integer here, okay. Oops, yeah, I'm gonna save. And 0xff09 09fc, and there we go, okay. So the mistake here was that I accidentally pulled some out of the inner by shifting stuff. Okay, but yeah, basically that should give us the colors we want. The 254 gives us this by shifted thing, which if we plug it in here now, after all the time we wasted, let's go ahead and try it out. So let's go ahead and put, for example, 15, 150, 240. Alright, let's run this. Oh, that's my bad. And now we get a new number, so let's go ahead and go over here. Control C, and we're gonna go ahead and set this to be our new number here. And now let's go ahead and see if it changes the color. I have no idea. Okay, I think that's the right thing. I'm making it something a bit more drastic, so how about 255 or 000, which should result in everything being 0 here. Let's go ahead and copy this. Let's set this to the new address. Now let's go back there. Black, and it is. Let's go. So yeah, that's how the basics of reimplementing a function is, and considering this is my first attempt, I'd say not bad. Alright, let's change this code to more. Alrighty, 50. See how this one looks. Just mess around. And then you could also do the same thing and reimplement it in Rust. Any programming language you could think of. It should be the same process. And yeah, color change. Nice. Now we can make our own colors in Python and then change it over here. That's about it, I guess. We learned how to intercept the normal value from a param, learned how to get a values from a structure, and how to watch a value, and then how to reimplement a function in Python. I think that was a good session. So thanks for watching. Not watching. Oh my god. I need to watch. Okay, that's about it. See you guys later. Bye bye. Whoopsie.